Hello everyone, I'm Sudha Udaya. Welcome to today's unit in the Building and Construction program. Before we begin, I want to remind you of the purpose of this program. Each unit is designed to give you the knowledge, skills, and industry behaviours required to become a competent and confident building practitioner in Australia. Throughout this course, I'll be drawing on more than 30 years of hands-on experience in residential and commercial construction. My goal is to connect the theory directly to real project situations, showing you how the National Construction Code, Victorian regulations, WHS requirements, and industry standards apply on actual work sites. As we move through each topic, think about how these principles translate into the decisions builders and site managers make every day. By the end of each unit, you should feel more prepared to apply these concepts in practical, safe, and compliant ways on the job. Let's get started. Today, we're covering CPCCBC4053, Apply Building Codes and Standards to the Construction Process for Class 2 to 9 Type C buildings. Over the next 20 minutes, we'll focus on three key areas: classifying buildings, working out NCC compliance requirements, and identifying fire protection requirements. This unit is about being able to access, interpret, and apply the relevant building codes and standards for NCC Class 2 to 9 Type C projects. The goal is to confidently find the right NCC information for the building you're working on and apply it correctly to real construction decisions. By the end of this session, you should be able to classify buildings using the NCC, determine construction compliance requirements from the NCC, determine fire protection requirements for the building type. Classify buildings. We'll start with building classification, because classification drives everything that follows, especially NCC provisions for design, construction, safety, access, and fire requirements. Determine nature of building, its use and arrangement. The National Construction Code, NCC, sets minimum requirements for safety, health, amenity, and sustainability. A key first step is understanding what building work includes, because it covers more than new builds. Construction, alteration, extension, restoration, repair, plus related work that supports the building outcome. Construction plans, working drawings, and specifications. To classify a building correctly, you must read the plans and specifications properly. Plans should clearly show what is being built, where, and how key elements relate to each other. So classification decisions are based on evidence from documents, not assumptions. Specifications. Specifications are the written technical requirements for materials, workmanship, and quality. They also support compliance because they record what must be achieved. Good specifications are project-specific and clear, so they don't create confusion during construction. What is an appropriate authority? An appropriate authority is the person or organisation with statutory responsibility to approve building work and enforce regulations, often a building certifier or building surveyor. If classification or compliance is unclear, checking with the appropriate authority helps prevent wrong assumptions and expensive rework. Australian standards. Australian standards support construction quality and compliance. When using a standard, always confirm whether the standard is referenced in full or in part. Which edition, amendment, is the one adopted for the project? This matters because not every update is automatically adopted into the NCC. Building classifications. The NCC classifies buildings based on nature, use, and arrangement, using Class 1 to Class 10, sometimes with subclasses like 9A or 9B. In this unit, our focus is Class 2 to 9 Type C buildings, so classification needs to be accurate from the start. Mixed-use buildings. Some buildings are mixed use and may contain more than one classification. For example, a car park, retail, and apartments in the same building. Each part may be classified separately, depending on how the building is used and how much floor area each use occupies. State territory legislation. The NCC is given legal effect through state and territory legislation, and local requirements can apply. That means classification and compliance decisions must always consider NCC requirements, the relevant state territory acts and regulations for the project location. Sustainability principles. Sustainability is now a standard part of planning and construction. The practical focus is reducing environmental harm and improving outcomes through better materials, energy efficiency, and responsible construction practices, while still meeting all NCC and regulatory requirements. Licenses and permits. Before building work starts, required licenses and permits must be confirmed. Depending on the project, this can include building approvals, trade licenses, development applications, zoning approvals, and fire safety approvals. Getting this right early supports a compliant construction process. Determine construction compliance requirements. From NCC. Now we move into NCC compliance. Once the building classification is confirmed, the next step is identifying the NCC requirements that apply and how the project will demonstrate compliance during design and construction. Identify NCC performance requirements relevant to Class 2 to 9 Type C projects. The NCC is a performance-based code. That means the focus is on achieving required outcomes, rather than only following one fixed method. The key idea is to understand the required performance first, then select a compliance approach that proves the building meets those outcomes. Relevant performance requirements. Performance requirements sit at the top of the compliance structure. They describe the minimum performance needed for safety, access, health, and amenity. Your job is to confirm which performance requirements apply based on the building classification and project scope. Structural stability and resistance. Structural compliance means the building must remain stable and perform as intended under expected loads and conditions. This includes resisting damage and avoiding structural behaviours that cause loss of amenity, like excessive deflection, settlement, vibration, or instability. Fire protection. Fire protection requirements aim to maintain structural stability during fire, control fire and smoke spread, and support safe evacuation. Compliance can involve passive fire resistance, active systems, protected paths of travel, and access for firefighting, depending on the building type and risk profile. Access for people with a disability. Accessible buildings must provide dignified access for people with disability. This includes approach paths, accessible entries, and access to key spaces and facilities. Design decisions must reflect both NCC requirements and the relevant access standards that apply. Health and amenity. Health and amenity requirements cover things like damp and weatherproofing, rainwater and surface water management, and suitable sanitary facilities. The intent is to make sure the building is safe, usable, and doesn't create unhealthy conditions for occupants. Determine range of criteria to ensure compliance. There are different ways to comply with the NCC, including deemed to satisfy, DTS solutions, following prescribed provisions, performance solutions, proving compliance through assessment methods, or a combination of both, DTS and performance. The key is choosing the method that fits the design while still proving the required performance. Compliance monitoring. Compliance is checked through audits and inspections, including reviewing documentation and site inspections. Good practice is to keep records organised, ensure evidence is available, and make sure site work matches the approved approach, so compliance can be demonstrated at any time. Identify and document non-conforming methods. If construction methods or products don't meet requirements, they must be identified and documented. Non-compliance can impact quality, durability, safety, and legal outcomes. Early identification prevents defects becoming embedded in the build. Remedial work for non-compliant buildings. Remedial work decisions follow a structured approach to determine whether an existing building meets current performance requirements and what upgrades are needed. The key is evidence-based decision-making, using documentation, inspections, and assessment methods. Propose and discuss performance solutions. When using a performance solution, it must be discussed with the right professionals because compliance needs technical input. The solution must show it meets all relevant performance requirements, and it must be assessed using accepted assessment methods. Stakeholders. Stakeholders can include clients, project teams, consultants, regulators, and suppliers. It's important to identify who influences decisions and approvals, and make sure they have the right information at the right time, especially where compliance decisions affect cost, time, and buildability. Strategies to stakeholder engagement. Stakeholder engagement works best when communication is clear and planned. Focus on using simple language where needed, confirming understanding and expectations early, keeping decisions and approvals documented. This reduces disputes and helps keep compliance on track. Factors to consider in choosing compliance solutions. Choosing between DTS and performance solutions depends on factors like cost and time to develop the solution, risks and consequences of failure, client needs and design constraints, existing spatial limitations and buildability. The best option is the one that achieves compliance and is practical for the project. Evidence of suitability requirements. Evidence of suitability is how you prove materials and products are appropriate and compliant. Evidence can include certificates, accredited test reports, accreditation, or professional certification, depending on what the NCC and the appropriate authority accept for that situation. Prepare a performance-based design brief, PBDB. A PBDB documents what is being proposed and how compliance will be proven. It typically includes building description and objectives, relevant performance requirements, the agreed assessment process and acceptance criteria, supporting evidence required and reporting format. This becomes the roadmap for the performance solution process. Prepare a final report. The final report pulls everything together, showing the assessment method used, results, and evidence that the solution achieves the relevant performance requirements. Clear documentation is essential because it supports approvals and provides a record for future review. Determine fire protection requirements. In this final section, we focus on fire protection, understanding passive and active systems, the required resistance levels for Type C construction, and how to check compliance for the building's fire safety measures. Identify NCC and other legislative requirements. Fire safety starts with understanding fire risk. Fires are classified based on what fuels them, and fire safety systems are designed to warn occupants, support safe evacuation, restrict spread of fire and smoke, suppress fire, and assist firefighting response. Passive fire control elements. Passive fire control is built into the structure. It's designed to contain fire at the point of origin and limit spread, often through compartmentation, where the building is separated into manageable risk areas to slow fire and smoke movement. Fire-resisting building elements. Fire-resisting elements include materials and assemblies designed to resist fire and reduce smoke generation. The required performance depends on the building classification, fire separation needs, and the NCC provisions for the specific construction type. Fire doors. Fire doors protect openings and support compartmentation by maintaining the integrity of fire separation. Correct door type, installation, closing mechanisms and maintenance all matter, because a fire-rated wall is not effective if openings are not properly protected. Active fire control elements. Active fire control elements respond to heat, smoke, or fire, either automatically or manually. They include early warning systems and firefighting equipment, and they support both occupant evacuation and fire brigade operations. Portable fire extinguishers. Extinguishers support early response, but selection must match the likely fire class. Placement also matters, usually near exits and away from the most dangerous ignition point, so occupants can access them safely during an evacuation. Emergency lighting and exit signs. Emergency lighting and exit signs support safe evacuation when normal power fails. They must be visible, correctly placed, and supported by backup power. The purpose is to prevent injury and guide occupants quickly to exits under emergency conditions. Automatic fire sprinkler systems. Sprinklers are designed to activate when temperatures rise and control fire growth. They can include pumps, pipework, storage, alarms, and connections for fire brigade use. The system must be appropriate to the building risk and compliant with relevant requirements. Determine level of fire resistance required. Fire resistance is expressed through FRL requirements for key building elements. For Type C construction, the NCC identifies minimum FRLS for elements like walls, floors, beams, and columns, depending on building classification and where the element is located. Check existing building for compliance. Checking compliance means confirming both passive and active fire measures meet NCC and relevant Australian standards. The practical approach is identify what systems are required, confirm what is installed, and document gaps for rectification, so compliance can be demonstrated. To wrap up, today we covered how to classify buildings, how classification links to NCC compliance, and how to identify key construction and fire protection requirements for Class 2 to 9 Type C buildings. The big takeaway is correct classification, correct NCC references, and clear evidence and documentation are what protect the project, the builder, and the occupants. Thank you for following along. I trust this video has provided the guidance you need to successfully complete your assessments. I'm Sudha Udaya, and I look forward to seeing you in the next lesson.